all the way from Austria.
From Austria.
Austria.
Yeah, sure.
Christoph Dirk.
Hi.
From Oshimo, who has one of the few mass spec as opposed to OES machines that test salt water and has a lab that does an unbelievable job. In fact, it is the preferred choice of moonshiners, yes? And you have a relationship with him. Welcome.
Thanks very much.
Welcome.
Fantastic to be here.
And thank you for coming.
I have a question.
Guys, go.
I got a question before we get into the nitty-gritty. We all do these ICP tests. Can you walk us through the process of an ICP test from when you receive that sample?
Yeah, sure.
And also, how long does that test take to run?
We receive the sample, and like the days, the sample we're getting from the US, we're usually measuring on the same day. So this is like coordinated quite well. We have a laminar flow. This is like a workspace that has very clean air, like flowing down all the time. This is the place where we open up the tubes that we don't have any contamination entering it. And
Excuse me, I know we talked about salinity being affected by temperature. Are these samples stabilized before temperature before you
we let them
process?
Equilibrate at the laboratory. We unpack them and let them sit to get room temperature. We also homogenize them if they were frozen during shipment to have it like homogenized again.
Is that all done manually?
That's manually, yeah. We take out an aliquot of the sample for ion chromatography because this is the process that takes the longest. So this ion chromatography runs overnight to have all the samples tested, or even the next day, yeah. This is half an hour a run. And this ion chromatography, we need it to have really high accuracy on calcium, potassium, sodium, like on this magnesium, on the really major ions. And also we need it for nitrate, for nitrate, for fluoride.
So the same machine that's doing fluoride is doing nitrate and also
potassium
and also the big guys.
Yeah, we're doing the big guys. We're doing it on the ICP and on the ion chromatography. So we get two independent values and can match them and see if there is any differences, because this would mean we would have an error somewhere. Yeah, so this is also part of the internal QC to have those compared. So this is ion chromatography where we get all this data. Then we put it into the ICP, depending if it's MS or OES. This is just put in an autosampler. The machine is freshly calibrated, consumes a lot of argon gas when it's running. So
we try to vent the argon out.
It's not so easy. Yeah. This is like 3 minutes per run.
It's calibrated. How often is the machine calibrated?
Every time we measure. Yeah, this is
every test.
Not every test,
every
but
day?
It's a sequence. Like when we're testing today, we're testing all the samples we received that day, and before we start with the testing, there is the the tuning and the calibration of the machine. Right. Then we have like control samples, which are like supplied by the European Commission. So this is really like, high-grade reference material.
Standard.
It's not standard, it's a reference material that you get sent, and you have really specified values for that. And we see, okay, our calibrations are spot on, yeah. Then we measure like the samples, and every 15 to 20 sample, we have this QC sample measured again to just see if we have the stability throughout the batch of samples. This is the ICP. Then we take out an aliquot of the sample, of the big tube, go to alkalinity titration to get your alkalinity value. We stick in a conductivity probe to get your salinity measurement. And we take out, you have this blue cap sample that comes with the stabilizer. We add some chemicals to that to do the phosphate test and add this to a photometer. Yeah. Then we compile all this data into the report and send it out.
Other than the part that runs overnight, how long is it from when the sample enters the machine for that results to be generated?
The ICP test itself, like the calibration takes like 90 minutes, something like this, yeah. And warm up before is even also like 40 minutes. But the actual measurement time per sample for the ICP is like 3 minutes. So
3 minutes, you get your answer.
Yeah.
Hey guys, sorry, I gotta run. I gotta go pick up a shipment of fish at the airport.
Where does Oshimo want their traces to be? And you seem to be more interested in at least bioavailability and absolute numbers.
The absolute numbers, they cause a ratio. Yeah,
They do cause the ratio.
I don't need the ratio extra because if I have two set points or two ranges, that causes a certain range of ratios.
Right. Are you a boron freak? Do you like it a 5 and above, or are you okay with 4.5?
I'm not a boron freak. I'm okay with 4.5.
You are?
Yeah, but shouldn't be above like 8-ish.
What was the whole purpose of the elevated boron to 7? What was the genesis of that?
There has been a history of boron being reported low on some ICP tests. Yeah, I think this also might have caused like some elevated levels. And boron is a not very toxic compound or element. So people are also experimenting with slightly elevated levels. I think Andre also has slightly elevated.
Slightly, what is it, a pH boost? What am I getting?
Better availability, but that's not really necessary, like in my experience, but doesn't hurt as well. So with boron, you have a very large play field, so to speak.
Yeah, I mean, years ago, Seachem used to make their reef salt at very high boron.
A little bit boron has influence on the alkalinity, but the carbonate system is the better contributor. Boron is not very problematic. You must never have too little. Yeah, this has effects on LPS especially. Right. Yeah. But if you are at the set point, at our set point, or a bit above, that's not so concerning, yeah.
And bromide, are you a bromide freak, or in the 60s, 70s, doesn't matter?
In my experience, it has not that much of an effect, yeah. We shouldn't be too low, we shouldn't be too high. If we are very high, we should be careful with ozone, because we can form bromates.
Yeah, how do you protect against that carbon? Maybe your carbon, when you get a little hole in that lateral line disease, but your bromates are okay. Okay. Are you a potassium versus calcium? We've interviewed other people that really felt that calcium should be higher than potassium.
No, potassium is very important. You mustn't have it too high. Yeah, if it's potassium is too high, you can hurt your fish. It can be dangerous to your coral.
What's too high?
Too high.
500?
500 is too high. Yeah, I wouldn't expect losses at 500, but at 600 I would expect losses. But like 500 is starting the danger.
And where's too low? 375?
360, depending on your salinity. If your salinity is at 35, we should have it above 370. 370 to 420, that's like the
in that range.
In that range. Let's say you have potassium of 600, which is dangerous, yeah? If you have calcium at 800, this wouldn't make the high potassium any less dangerous.
Right,
yeah?
right.
So in my opinion, in this case, better to see those values isolated, and you need both values in the ideal range. Yeah, you mustn't have elevated calcium and you mustn't have elevated potassium.
By the way, there was a while where Polo Reef had elevated calcium, and it actually hurt the system. And we actually had to remove aragonite that was melting.
Okay, but calcium is less harmful than potassium in this regard. Yeah, it's a more can be more tolerated by coral, but the growth definitely goes down if it's elevated. But if you have both in your ideal ranges, that automatically like sets or defines a certain ratio between those two.
Of course,
which is like in the 1 to 1.
All right, but if they're both 420, that you're cool with that.
Absolutely, yeah.
Okay.
And if your potassium is like 410 and your calcium is 405,
yeah,
like, that's not an issue, yeah.
Okay, all right, that's great. For people that have sulfur reactors, or there are some salts that I know,
that
particularly European ones, that are even low.
That's interesting, because in European reef tanks we see more of too low sulfur or sulfate values.
Yep.
While in US tanks it's more of the opposite.
Right.
Yeah? It might be because Epsom salts like magnesium sulfate, sulfates are more used for magnesium dosing.
Yep.
There is also some salts on the US market that have a higher sulfate value. And the use of sulfur reactors is more common.
Where, here?
Here.
Here.
Yeah.
Because the aquariums, and just in general? Big systems?
Big systems, like small tanks don't use it because it's too much effort to keep it running.
Right.
But if you have a bigger system...
what do you want your sulfates? Between 25 and 3?
Again, very much dependent on salinity.
Yeah,
but 2.5 to 3 is
2.5 to 3. Above 3, you don't like it anymore. Before we did the special water change, we almost got up to 3,200.
Yeah. And you see negative effects. Yeah.
We saw negative effects.
You don't see them right away until they they're creeping up,
Yeah.
start seeing the little negative effects become larger and larger, and then boom.
Yeah.
So
I've also learned from your experience here, because we haven't been confronted very much with elevated sulfate levels.
Right.
Personally, I would have thought it's not that problematic, yeah, but your experience clearly shows it has a negative
I
effect.
mean, for the fish or the mammals, or it's not gonna. I don't think they care. I think it's the corals.
from what we're talking about, like sulfate reactor, which is being used here to remove nutrients, right?
Yeah, yeah.
Now, other reefers have other methods of removing nutrients,
Right.
Right? Which, to your studies, you're finding out that depending on how you're removing your nutrients, let's say GFOs, right, are also removing with them
A lot of trace elements.
Tons of traces.
Yeah, sure.
And sulfate too, you said, right? The sulfate reactor is pulling a lot of a sink for, what'd you say, iron or something?
Could, like, almost all trace elements.
All traces. They
really
both do.
how are you going to calculate without sending an ICP test? Because the whole study is like, you send ICP tests for the first month, 2 months, 3 months, and then once you get it all down packed, you're dosing this every day. But you're still failing on that every day, because if you change or tweak one thing on your
Influences
nutrients
another.
removal,
That's a way to send quite frequent samples and to keep your husbandry as stable as possible. Yeah?
Right.
If you have a tank dialed in on traces, including ultra traces, and you're adding a huge GFO reactor, or you're removing your sulfur reactor and adding a refugee.
Right.
This will really,
Change
all
things around.
all the trace element levels, because you're just changing your export functions.
Right,
yeah?
right.
So you would need to dial it in again.
Right,
Sending more
right,
samples, yeah?
right.
But when you keep your feeding stable,
That's what it is.
when you change your feed, yeah, that could change the trace element levels.
You said, we talk about GFO.
Yeah.
Right? Well, I mean, I don't even want to tell you. It's embarrassing how many buckets of roa that we use at a time. I mean, between our salt, I'd say our salt and our roa bill is probably the highest, maybe
Running
other than
Okay.
food, which is just 5 pounds a day. It's because, okay? Should I be doubling up my dosing a day or two after I put new GFO in?
It's really hard if you double it up or
well,
increase it to
that is the
40%.
test we need to do.
Yeah.
It
We need
can't.
to
It wouldn't hurt.
so we need to be smarter when we send the test to, if it was at the end of the GFO, it was after we replaced the GFO, after a water change, which we did that.
Yep.
It is important because same thing goes to the carbon.
Yep.
Carbon also removes.
A little less, a lot less, a lot
right?
less.
For me, for example, me as a reefer, I use zeolites. Now, zeolites are producing certain elements.
Yeah, yes.
Right? Instead of
we just
taking-
learned that,
I
that it's
just
good for
learned that.
barium. You would be good with the pom-pom algae because it would remove the barium.
And I put it in more to keep my iodine in control, because my iodine is always high.
Right.
Because it does remove iodine. So it does, I believe, remove.
It does. So zeolites removes iodine.
No, yeah, a little bit.
Little bit.
And carbon as well. Yeah, but that's not that pronounced.
All right, let's keep going here. You have a magnesium preference, or do you not care? 1300 to 1400?
Magnesium is so unproblematic. You just
Yeah.
need to be like in
In
this
the-
range,
somewhere.
in
Somewhere.
range.
Okay.
You don't need to pinpoint it.
Okay, fine. Barium.
Interesting ion, yeah, because it has no real biological function, but it's present in natural seawater, and it clearly is deposited into coral skeleton. And if you don't have barium present, it's not deposited there because you don't have it in the water, which of course changes like the structure of the skeleton. And I'm a believer that we should have at least like the natural concentration of barium, which is like in the range of 5 to 7 ppb.
5 to 7.
5 to 7.
Right.
A little bit above doesn't hurt.
Okay.
Too low, we've seen negative effects that
Too low is going to be like 0.
like 0, 1, 2, yeah.
Right.
And we see this regularly and seeing
So
positive
barium
effects,
on
yeah.
on Polo has 17.
Yeah, that's perfect.
That's perfect, even though 5 to 7 is natural.
We've seen that like slightly elevated concentration.
fine?
Is fine, yeah.
In the 250s, when the red algae was sucking the barium, we would have 5 or 3,
Okay.
and we'd have to dose it.
I would recommend it, yeah.
Right.
I think Andrew recommends it as well.
Yeah. I mean, frankly, we got so tired of it that we took the red algae out.
You could add some zeolites to, like as a constant.
We
supply.
did.
We
Yeah?
did. We
Okay.
did. We still
In the bag.
Yeah.
Remember?
Yeah. Chromium.
Yeah, I'm a chromium freak.
Are you?
Yeah, I'm a
Are
chromium-
you?
Yeah, sure. It's one of the more important.
Which
like-
comes to a very important point. Keep going, Andrew.
Yeah.
Yeah,
Because only your ICP test shows a number.
Right. That.
Other ICP test shows it non-detectable. So
usually.
now,
Yeah.
I think I'm a genius in this reefing hobby, and we all get into very comfortable that, you know what, let me dose a little bit, it's undetectable, right? But in theory, because someone else does, but in theory, I could be now overdosing because
Sure. You don't know where you are. Yeah.
I don't know where the value is. Only your ICP test showing a value. Cobalt as well,
And selenium and copper.
and selenium and copper.
Yeah.
So I think that is an important thing for hobbyists to know, that if you get someone else's ICP test and it says non-detectable,
Don't
just
freak.
don't go on
Don't
your-
go freaking.
and start dosing on your own.
For several elements, it's not a good idea to dose them into detectable levels by ICP OES. For example, selenium, if you would dose it to detectable levels, factor 200 to 300 above the concentration you want to be at. But it's really known to be an essential trace element. And we are selling selenium as a supplement, and sometimes people approach me and want to buy selenium, and I check if they have an analysis with us. Then I see, okay, they don't have an analysis, and I ask them, okay, why do you want to dose this? Yeah.
right,
Then
so-
they show me an
So chrome, you like to be where?
like at 0.2 to 0.5, so below 1 microgram per liter.
I mean, what happens if I'm 0.13? Is it-
You're getting too low. Doesn't mean you have like direct negative effects, but it's like borderline low. So I'd recommend you to just lift it to
My dailies, my dailies.
the dailies.
Right.
Those are the elements that are consumed rapidly.
And what does chromium do besides rust with stainless steel? What does chromium do?
Can be a source. It's like that. The answer is a very general one. For many of those trace elements, like copper, like chromium, like nickel, those transition elements are like in the core of enzymes, and have a very important function in those. The enzymes are like biocatalysts that have like functions in metabolism. Yeah, and if the metal is not like in the active core of this enzyme, the enzyme doesn't work. There is a certain pathway in metabolism that can't be done, or that cannot be done efficiently, because there is only such a little concentration. So you might be limiting your growth, you might be limiting your health. It's just growth retardation and possibly also like die-offs.
So that's the reason why you like it more so than others.
We're a bit more above natural seawater levels. So if
Where is natural seawater when you test chromium?
for chromium, it's below 0.1.
Below 0.1. Okay.
It's
okay.
like natural seawater.
So
is,
close to this, 0.13.
yeah, might even be lower.
Oh, lower. Okay.
But like the open sea is like not a closed system.
Right.
So you have one wave and like it's replenished.
Right.
You've got it there all the time.
And on the amount of food and plankton and zooplankton in the ocean is just so much
run
more.
out. Yeah,
You don't
have
run
an
out.
Eternal supply, basically. I mean, just if the coral would take up like all the chromium or all the trace elements that is close by, there would come a wave, or like the flow would just
New
bring
water.
And we again have the availability. Yeah?
Okay. The
So we have-
bioavailability has to be there.
While in the tank, you might quickly, if it's like consumed, you
still
might
go
drop
up on the
below a
dailies and
problematic
chromium.
level. And you really see a difference when you're chromium deficient. You see that the corals are not looking nice. You don't have that.
Cobalt.
More or less the same as chromium, but our set point is a bit lower because chromium, as copper, has the ability to act as a toxin. So we're
Cobalt too.
careful. Cobalt too, we're careful with dosing. It's also in vitamin B12, cyanocobalamin.
Which means you're getting it in food and stuff like that?
Yeah, like all trace elements are also present
A lot in food, yeah.
This is what I call unintended dosing.
Yep.
Yeah.
But that's very important for reefers to understand, that there's a lot of ways that corals can both uptake the trace elements. It's going in food.
Into the water column,
Yeah,
There is unintentional dosing and intentional dosing. And in some tanks, some people say, we never dose any trace elements till the tank is nice. The answer is the unintentional dosing. That they're dosing them, but they actually don't know it.
The unintentional dosing is their dosing.
Right.
Exactly. Yeah.
Right.
They just
And
don't
they think
know
they're
it.
doing well.
And there are a few friends of mine who actually have beautiful tanks.
Yeah, sure.
Iron. Why on one test am I getting 1.5 and another one non-detectable? Like within, is that a function of when I change my GFO or like could that be?
Like were those samples drawn at the same time?
Well, that's the whole thing. Is we dose our iron twice a day.
You have
One could have been sent.
That's a different. That's an OS and that's a mass.
Yeah, but on iron, OES is good as well.
It's not detectable.
Yeah, it's just a function. We dose it twice a day. So if it was between number 1 and number 2, it might be less than when after you dose the second batch.
Could make a difference, like a few hours in difference in sample taking. Could also just have slipped through the detection limit of the OES machine, because like around 1 ppb is like the limit of detection for iron.
Okay. Do you recommend dosing iron on a doser throughout the day?
Every time we measure, every time we turn on the ICP machine, I measure our tank as well.
Yeah.
And I dose iron like twice a day.
Twice a day, like
as you, like my trace element mix. And I always have it detectable. But also depends on your export. Yeah, if you're having very heavy export, very heavy skimming, like very extremely high pH, might not be true like in every case.
We've had to go from Andre's regular to his 10x.
Okay.
And then the other thing is we even use Bob Stark's transition elements because it's stronger. We doubled that amount. I mean, the iron must be between the ozone and the GFO, and I mean, it must be just staying in the solution not long.
Iron always precipitates.
Right.
Yeah, this has just a strong tendency.
And it shows this there because the green colors are amazing.
You're doing fine, and the good thing with iron is you can't really overdose it. Yeah.
You can't overdose it.
No,
You will
iron
only
is
get
not-
aerology, that's all.
You might get massive precipitation of iron, which is not good, which might fuel cyano if you're having bad luck. But if you dose like in normal reef aquarium levels and not overdose like 1,000 times, there is no issue to be expected.
Okay, I heard a story once that there were no acroporas that grow on those old ships that get sunk because the iron was too high.
I've heard otherwise that there actually are growing corals on those ships. I need to go diving again.
Yeah, go check that out.
Yeah, I will.
All right. Fluoride.
Fluoride is very important. It has a strong interaction with calcium. Yeah, this is why it gets also deposited in the skeleton, from what I've read, but I don't know if it's really how good the experimental basis is to support this, but it's very logical, is to have like a hardening of the structure.
Oh, it's no different than
You have the fluoride toothpaste. Yeah,
and they put it in the water supply. Okay, you like that to be as low as 1 and as high as 1.5?
1 to 3 to 1.5. This is perfect. If you're slightly below, that's okay as well. If you're below 1, you should dose.
Bioavailability is the key here.
Yeah, as soon as the fluoride is in the water, it's bioavailable. Yeah.
Tell us why it's sort of a dangerous.
It's you don't have much much room between the dose you want to be at and the potentially toxic dose.
Okay.
So you don't dose it blindly. Have your lab analysis that measures for fluoride so that you don't overshoot. Yeah.
Well, we notice in this tank, for example, Apollo, that we probably need 250 milliliters of ESV fluoride a week. Just to keep it even.
Yeah, but for a size this tank, like 200 milliliters.
No, I understand.
So
it precipitates. It seems like you might go from like 1.2 to 1 over a week.
This can be really actual uptake by the coral,
right?
And it can be precipitation as well. That's really hard to tell.
Now, does it if it precipitates, does it also remove other things with it, like manganese? Though
we never investigated this. Could potentially happen. I wouldn't expect it to be as pronounced as with the manganese. It's when you have salts that are high in manganese and you mix them up, and you have like your salt mixing station, and you have this smear of like brown stuff like on the
sides,
on the surface of the container.
On the surface, yeah.
And when you take this and you analyze it, you find a lot of manganese and iron. That's high in salt.
And that's what's high on contaminants in these salts.
It's a high contaminant, yeah, and this wouldn't be an issue because it precipitates anyway, so it doesn't really, cause a lot of issues in the reef tank, but it takes a lot of trace elements with it. So we find all the other traces and also some pollutants like in this brown stuff on the surface.
Which means your water change water could actually be light in trace
Could
elements.
deplete in trace elements. Yeah.
Right. Iodine.
Many people think it's not important, including like respected chemists. Honestly, I can't tell you what iodine does. I can tell you what it does in the human body. It's important for the thyroid hormones and so on. I can't really tell you what it does for the coral, but we see very strong effects. If you're iodine deficient and you dose it, there is a massive positive reaction by the tank. So we keep an eye on it. It's difficult to measure on the OES machine. It's much more easy to measure on the MS machine, and we try to keep it between 50 and 80.
Fauna and Claude have a thesis that if your nutrients, nitrates and phosphates are low, your iodine could be 30, 40 or on the low side. But if you're running 0.1 phosphates and 10, 15 nitrates, he wants your iodine closer to 100 or on the high side, 80, 90.
Okay.
I don't know what the relationship is between the nutrients and the iodine.
We never investigated this.
Okay.
I mean, of course, if you have factors that cause higher growth, for example, you improve your lighting, you improve your flow, you're having better coral growth. You have to keep up, and maybe it's better to have a bit of a higher concentration to have more safety margin if there is this massive uptake of coral.
Okay.
But yeah, we never investigated this, if like 100 of iodine is better in a higher nutrient setting.
Iodine, iodide.
Yeah, that form.
Yeah, that's interesting. It's
Because,
also...
there is a company, I'm not going to mention names, that I use,
Yeah.
and I'm basically dosing potassium iodide with fluorine,
Okay.
right? So there's 3 elements in one.
Yeah, but the potassium is like a negligible amount. Yeah, iodine comes in different forms. Yeah, there is
Lot 3?
there is even more if you count organic iodines. Yeah, organic iodine species, but there is elemental iodine. This is what's inside this brown iodine stuff. This is a very reactive element. It can oxidize things. Once you put it in the tank, it oxidizes things and reverts itself to iodide or iodate. But on the way of oxidizing things, it can change other parameters, also your redox values and so on. So there is only 2 that are common in the reef tank. This is iodide and iodate.
Okay.
Iodate is usually the dominant species that's in more oxygenated water, like surface reefs. There is less iodide, but more iodate. And this forms, also if you dose iodide, it transforms into iodate into your tank.
Right.
Right, so let's say you take the moonshine. Can you mix those 3 together?
No, he actually recommends, I believe Andre recommends Seachem's iodine.
Yeah.
That's like Lugol's almost.
I don't know. I don't know what's so special about it. I don't think it is.
Is it colorless? Or
I
is
have it.
color-
Go get a bottle.
I think it is colorless from Seachem.
Okay, because
I think it is.
the colorless iodine products are all iodide. Yeah, the brown ones that stink, that have like iodine in it. Yeah, I don't recommend iodine dosing.
The iodine is the one you put on the cup.
Exactly. Yeah, to disinfect your.
When we were young and you basically had cuts, you went swimming and it healed from the seawater.
Yeah.
Ooh, you like that, huh, Joe?
I think it was more the salt and
Yeah. Could have been the salt cleaning it out too. Oh yeah, that's clear. That's the Seachem iodine.
Okay, that's clear. So there is no iodine inside, it's just iodide. Yeah. But that's the preferred way of dosing it.
So now fluorine and fluoride.
Yeah, fluoride, there's just fluoride in the reef tank because fluorine is the most reactive thing you can imagine. If I would use elemental fluorine and I would put it like here on this can, like everything would start burning, just by the reaction with fluorine. And fluoride is like the ion, which is stable and not so reactive, but toxic.
This is well, I got 2 great ones. Let's talk about copper.
Copper is
It's one of those things that
two-phase. Yeah, usually when there is elevated copper is problematic when it's elevated.
Right. Where's that? Where's elevated for you? Above 3 or something like that?
Yeah, above 5.
Above 5.
Yeah, that's really elevated. Yeah.
And where do you like it? Like half to 1?
Half to 2.
Just there enough to do its job.
Yeah.
And
nearly detectable on the MS machine, but not above 5. Yeah, that's the way we'd like to be with copper. Usually when you have elevated copper, you might have some faulty wire, you know, the copper wire exposed to the salt water of some equipment.
We had a clay pot.
Could be as well, yeah.
Yeah, we had 2 clay pots in a 500-gallon system, and we were getting high zinc and high copper.
Wouldn't have expected it, but not impossible, yeah.
Pull them out, gone.
Copper is also one of the elements that precipitates rather fast. So when you're having high concentration, that means you have an active situation of copper influx. There you have something going on at the moment you take the sample. Yeah.
Right.
If you're finding when you remove the source and you send an ICP like 2-3 weeks later, copper must have declined by a lot.
The key, if you have too much copper, is to find the source. That's the key.
Yeah.
We know how to remove it. Cuprosorb, carbon, GF. Removing it's not the issue. It's
Finding the
source.
It's like a needle in a haystack often, yeah.
Right.
To find the source.
Yeah. It could be a leak somewhere or something.
Yeah, often it's the cables, often it's like brass fittings in the RO system. Yeah,
In the RO system.
Yeah, some people have like brass valves like behind the membrane.
Very interesting.
And the RO like dissolves a lot of the copper and the zinc from the brass.
Right, so that's why people measure the copper and zinc in the RO water.
Exactly.
Lithium, the US guys got it.
Yeah. More than the European guys.
More than the European guys. Why? It's their sodium chloride or magnesium chloride source. It's the mines.
It could be a contaminant in some of the mines. Yeah,
Right.
I mean the electric car guys, they're keen for lithium. We don't want
It's
it
not being
much.
removed by our RO systems then.
In the
It's
salt. It's never in the RO water.
It's not in
no.
the RO water.
No.
So it's in
It's in the
salt.
sodium chloride or the magnesium chloride.
But it's not very problematic. So if
Right.
above 1,000, I would
Right.
really do something against it.
Yep. God, I remember when it first came out and everybody had a fit that lithium was at 350 and the fish were all happy because they were on lithium.
It's funny though that what we're saying is because on some of the ICP reports, and they all come up with high lithium. Recommendation is a water change. How are you removing
You're
it?
not.
You're
Not.
putting it-
Standard.
taking it
It's a
in your-
standard answer.
But there is no other way to remove it. There is no selectivity in any of the media to
There's no other way of removing it.
No, because lithium is so related to sodium.
Sodium.
It's basically the same, chemically speaking, much smaller.
Right.
So there is no way of have any selectivity for lithium over
Very
sodium.
interesting. Can't get rid of it. Just got to live with it.
Yeah.
Or
I think-
change your salt. But you're
yeah.
saying there's no
It's-
reason.
If you're hovering around like 300 to
Yeah.
500, it doesn't matter.
A lot of them have it.
In Europe, when we have high lithium, it's usually more like contaminated additives like magnesium salts and so on. Or it could also be like ceramics, you know, like artificial reef structures that you put in the tank.
Yeah.
Or like reef cements,
Yep.
like the thing you
Yep.
use to glue
Yep.
everything together.
Yep.
We hit a little bit on that yesterday when we were chatting here about a fish tank with live rock versus fake rock. You know, it's funny because we had some info come from corals that are being imported, aquacultured with these cement bases.
Okay, yeah. You know, cement is a way to dispose of waste in an industrial way. You can put everything in. So
And
it's
obviously-
It's a great point, Joe. Like if you get a beautiful chalice and it's on one of those heavy
things.
brick.
Now,
Even the people that use the plastic frag plugs will get extra vanadium in their tank.
it's the ceramic plug.
The ceramic ones. Right.
right. So when they're in the ocean, obviously the ocean is big. It's making no difference. But when it's in a box, you know, that's going to release, and it's there.
A closed system
By
is
the
always
time I get
different,
3 ICP tests, I lost that chalice.
Yeah, take the bases off those
the bases
chalices.
off.
Of the cement chalices.
And
Take them off.
I always had a little reservation about what's going on in this hobby because I had few friends of mine that they had beautiful tanks. They're experienced reefers, beautiful SPS tanks, and they moved and they decided to put a new tank and they decided to go with this man-made rock
Okay, yeah.
because they didn't want to deal with the creatures that come in with live rock, right? And they cannot succeed anymore.
Okay, yeah.
And
Yeah,
they say, I just
understand.
don't understand. I can't take this anymore, and they get out of the
You
hobby.
wonder if it's the biome too, though. Like, who knows what it is?
But
Is it
once-
the organic side or is it the...
No, in my opinion, there's several aspects. Yeah, you can't denitrify because you like
You can't
porosity.
denitrify, right?
you
So your
put-
nitrates...
That's the point I'm trying to
Porosity,
come to.
right, right.
It's what we discussed yesterday. Now comes trace elements laying on holes that could just sit there and then they could just be released into the tank versus being sucked into and taken out of the tank. Based on what we were saying yesterday, could make a difference what detritus could pick with it.
Sure, and you have this aspect of like a man-made rock has a very active surface. Yeah, this is also ceramics that are coming out like of a 800-degree oven. This is really activated surface.
Right.
They can bind trace elements and they can release trace elements.
Correct.
Which is both also a factor, and many of these tanks have a hard time really starting. Yeah,
Right.
They have high levels of aluminium.
And I think that's what could be in some situations where these successful reefers were successful with live rock.
It's also the nutrients are a big point because a live rock always brings like a buffer for nutrients. Yeah, there is so much like organic stuff inside that releases nitrogen compounds, that releases phosphorus, phosphate. So you can't really, even if you're cycling a tank, you can't really deplete the nutrients if you're working with live
Some of
rock.
them can't even cycle.
That's wild. Okay. By the way, the Marco rock is got high porosity.
Okay.
It's real rock. The only problem with it is it gets a wicked, ugly dino phase and makes it brown and ugly for a while, which is why they're trying to culture
In
in
the
a
ocean.
pool,
Even in the
Polar
ocean.
line.
Now they have it even in Florida. Someone took a space,
Yeah.
rented a space, and they're dumping it in the bottom.
Yeah,
of the
yeah, yeah, yeah,
ocean.
yeah.
And it's building up this biome where then they bring it out of the ocean and bring it to you.
Okay, they bring it.
They're selling it to you as live rock now.
Yeah, that's fantastic, and it's sort of a live rock because
It sort of is, right?
Once
Right.
you put it
You know,
in a,
it's
in
a
As
a
long as it
rock.
wasn't fake to begin with.
Right. If I was to go and change my tank, and I probably would choose that. But with that could also come critters
yeah.
because it's from the ocean now.
That's
Right.
an interesting part because
Pests.
the pests as well. But what I found so fascinating from reefing from the start on was that you put something in and you don't actually know what life forms are there, and you keep watching, and then you have
Until you
here-
find a 3-foot bobbit worm
Yeah,
in
sure.
your head, like
That-
I did.
That's the downside to it.
Or maybe tons of serpent stars. What about the crabs that
remember
get
when
like
I,
this?
I remember when I started out, I had 2 crabs, which I didn't know they were in my tank. I don't know how they came in my tank, and they were bull
Okay.
crabs like this big
Yeah.
eating my fish.
Wow.
Yeah.
You know, and then the last one was the bobbit worm, where it was 3 foot long.
Okay. Wow.
And
Wow.
I don't know how many Leonardis this guy ate, because I think they went more after fish that slept in the sand.
Certainly a downside.
This brings such a huge variety of organisms that your tank could benefit from. I wouldn't bleach it.
Let's talk manganese, molybdenum, nickel.
Molybdenum, we see little issue. We like to keep it like at a natural level.
Yep.
We don't see
Which
much.
is where? 10?
10 to 12,
Okay.
like this area.
Yep.
Very unproblematic, can go up to 100, usually no
No
issue.
issue overdosing.
issue. It's-
Which is why
Which is
Joe, you come on, get.
I asked him yesterday. I'm a person that when I receive an ICP,
You're looking
test,
at the arrows.
I don't care about the arrows, but I do look at the arrows.
Yeah.
And I still look at the numbers, and then stumbled on molybdenum, where we were at 7 points higher than your highest
Yeah, we should maybe.
ideal value,
Yeah.
and you
And
still
they're
had
still
it
green.
I mean, yeah, it's.
It should be yellow up with an arrow up, I think. No.
Yeah, but yellow with the arrow up means you should do something, you should change something, which is not necessary in this case. And I could extend the
So
optimal
you need to come
value.
up with a different color.
Like yellow-green.
It's gonna be a different
Pink, you
color.
just don't matter.
That you could be high on this, you're good.
Okay.
Yeah, no, we don't want to stress out people.
Nickel?
Nickel important also
Yeah.
for the enzyme thing.
Yeah,
It's
yeah,
a
right.
important transition metal. Not so good on ICP OES, very good on ICP MS.
Yep.
Should be like in the 2 to 5 region. Can over.
So 5 is like the fauna range, and 2 is your range.
yeah, 2 to 5. What do you have? 1.7?
Yeah.
I would raise it a bit.
But we got a green arrow anyway from it.
Yeah, I should change that. Yeah.
Another color.
No, it's 1.7. You will not have issues.
Here's a really interesting one. Rubidium.
Interesting one.
Really interesting.
Really interesting one. Even most of the ICP OES machines,
Yep.
like the machine that most guys are having, can't measure rubidium because it has not so many emission lines, and this like in the red region doesn't work. So we started with the OES measurement that could read rubidium. So for the first time we got rubidium values for reef tanks.
Right.
And we figured, okay, rubidium is low in most reef tanks.
Because it's so expensive and the salt manufacturers don't put it in?
No,
Or they don't even know? Or
I think they didn't know.
They didn't know.
It's true, it's expensive, but you don't need a lot of it.
Right.
So
Right.
the overall expense for the salt
not a big
is-
deal.
Is not a big deal, no.
And so the typical salt might be 30, 40, or 50 rubidium, and you like it at
At 100, 150.
150.
Natural levels again, yeah.
Is that natural level?
Yeah.
That's not above 150.
It's 100,
100.
120, something like that.
And that's also like a one-dose thing. That's not something that changes a lot.
That's not consumed a lot. It's introduced by zeolites, like cesium, which is a related element. And with rubidium, there's also like absolutely no scientific basis why it would be important
For rubidium.
for rubidium.
But we want it up anyway.
I mean, we have it in the seawater, and we chose to dose it when we've seen, okay, we're much lower than seawater. Let's dose it. Let's see.
Just because let's get close to seawater.
Can't be wrong, right?
Right.
We got so many positive feedback. Yeah?
Interesting.
Especially with mushroom corals and much more expanded, and you know there is so many aspects in like coral reefs are still alien to us in many aspects.
Right. Science, for sure.
And nobody ever like explored the role of rubidium. Maybe there is some, yeah. It's related to potassium, so there might be some interaction with potassium uptake. You can't really tell. It has not been investigated.
Right.
Also, we didn't investigate it. We don't have the capacity to perform such studies.
Now, when you test salts out there, where do most salts fall in rubidium?
They've adopted and they're dosing it to 100.
They are. Most are now.
The European brands I'm aware of that we get into the lab that are usually doing it. Yeah, not all.
And the American ones?
We don't got so many American salts on the table on the lab bench.
Okay.
But like we get many reef moonshiner samples and they all have high rubidium.
Well, because Andre's selling them green bottles.
No, but I think they also have quite good experiences with rubidium. Though.
No, I think I dosed it once to get it up, and never again.
That's it. Yeah.
So it's not really something that's being uptake by the corals so much. In the ocean,
It's the same with potassium. Potassium is not taken up by the coral.
Right, potassium
in
is not-
significant amount. Still, it's very important. Yeah. So just because something is not being taken up doesn't mean it's not important.
But you would be adding potassium more frequent than rubidium, though.
Potassium usually doesn't decline when you have some media or some algae that
Algae takes it up.
takes it up.
Which again, falls back to what we said is nutrient control.
Yep.
Is what mainly probably is removing these elements. It comes to down. If it's not being used, then how is it going out of the tank and people are dosing? I dose potassium almost every day.
You have an algae reactor, right?
Okay.
So there goes the point to why some of these elements are being removed. Not so
Right.
much by the corals, by the mechanicals that we're using to remove nutrients.
This tank's potassium tends to be far more stable and not much change versus the lab tanks, which had the red pom-pom algae.
Now, tin is interesting because it's a pollutant we see quite often.
Yep.
And we figured that like dosing lines that come with dosing pumps, like colored ones, that some of them release like massive amounts of zinc, yeah? And we even broke it down and did some further analysis on it and found out it's an organotin compound that's added there likely as an anti-fouling agent. This is likely to have some impact onto tanks And now, since we found out that those are leaching tin, yeah, we lower like the average tin concentration in European tanks because people start avoiding those.
So I don't dose tin, but it showed up at 0.2. How'd I get it?
Yeah, trace elements are everywhere. Like
Everywhere,
feed
yeah.
in.
Yeah, I got it.
Yeah.
I got it.
There were some guys that had high tin.
Yeah.
They don't dose it.
I know.
Two possibilities. He's using those dosing lines. Yeah, ask him what dosing lines he's using. Or if it's a fresh tank, like a glass tank.
PVC or the brand new tank syndrome, right?
Yeah, it's like
the coating.
Glass is coated by zinc because it's manufactured floating onto liquid zinc. Yeah.
On zinc.
So glass has a tin. No, sorry, not zinc. Tin. Tin, of course. Liquid tin.
Yeah.
And glass has a tin side and a non-tin side, and you can differentiate between those. And the guys that glue together the aquariums should always check which is the tin side and have the tin side on the outside and not on the inside, of course.
That's very...
But that goes away eventually, right?
Yeah, but can take a while.
And removing tin, Coopersorb, GFO, the same.
GFO does the job. Yeah.
You want to talk about quickly Lathum and people that use Lathum for phosphate removal?
Yeah, lanthanum, we're really against the use for phosphate control. I mean, many use it and have no issues.
Right.
But I've seen quite many fish die-offs because of lanthanum. It's two factors: lanthanum chloride.
The gills in the zebrasoma in the tanks, right?
Especially in tanks. Yeah. They start breathing heavy, and some of them just succumb to it.
Right.
It's the lanthanum itself that is toxic. There is publications out there really showing like tox studies.
Yep.
And it's also the lanthanum phosphate, which is like a squishy precipitate.
Yep.
And this can also like glue together the gills, rendering them less efficient.
Do you see any effect on the coral when you test for Lathum elevation?
Could be on mollusks, like on
mollusks.
Tridacna is more susceptible.
A clam or something like that, but not this kind of stuff.
No, Acropora and so on. They don't really care too much. Yeah.
Got it. All right. Well, I'll close up. You guys have any final thoughts?
One last question.
Okay. Yeah.
If you were a reefer like us, which you are,
I am,
as a hobbyist, from all of these names of elements and stuff like that, is there one that you know that you will not live without?
I wouldn't leave without any essential trace element.
There's the answer. He wants the whole package.
Yeah, I mean,
he wants the penguin. All right, guys, you heard it here. Click and subscribe. Oshimo.
You can subscribe to us as well.
Yeah,
it'll be a pleasure.
This is the mass spec test of our choice for the trace elements. You can get them through the Moonshiners website. We are going to be doing a giveaway so our followers can see what a mass spec
looks like. Looking forward to your samples.
Yeah. Check them out and keep up with your trace elements. All right, guys. Thank you very much. Thank you, Christoph.
Thank you very much, Andre. It was a pleasure.
Pleasure.
All right. That was good. That was very good. I learned a lot.
'Cause this is what I live for. I never quit, no. This is what I live for. I take another swing, so I never miss, no.